The example 1.16 of the first chapter is we have to use dimensional method to find the expression for force acting on a particle that moves in a circle. So here the assumption is, what we are supposed to do has been given in the problem. So if a particle moves in a circle, and we might think that, you can assume safely that the force acting on the particle towards the center, which we call centripetal force, depends on mass of the particle and the speed with which it is revolving around and the radius. So because when the radius changes, the force may change. When the radius when the velocity changes, force may change. So it depends, but the only trouble is how much they are going to change. Whether when the radius changes, force is going to double or it is going to triple. When the velocity changes, force is going to may become 4 times or square root of velocity. That thing we don't know. So what we are going to do is we are going to compare the dimensions of force with the dimensions of quantities on which they depend. For instance, here what they have given is force. It may be proportional to mass, it may be proportional to velocity, it may be proportional to radius. But to what extent? The mass square or mass power 4 or mass power 4, we don't know. So force proportional to mass power A and velocity power B and radius power C. When you combine these three, you can write it as force is equal to some constant we have to introduce. And the only challenge with the dimensional analysis is if the constant has dimensions, this method will not work. And the constant will work, this method will work only when the constant does not have dimensions. Here they have asked us to assume the constant's value is 1. So V power B and R power C. So what we can do is, this is 1, so F is equal to M power A, V power B, R power C. Now let's write the dimensions. If force is equal to this, then the dimensions will be equal, because you can equate only apple with another apple. So we know that force is equal to mass into acceleration, and dimensions of force is dimensions of mass and dimensions of acceleration. Mass is m, acceleration is L t power minus 2. If you don't know this, go back and just check the book, we will do that. So mass, dimensions of mass is m, and dimensions of velocity is actually meter per second, that is length by time, so L t power minus 1. And R is the radius is the distance, so R, the dimensions of R is just L. So we are going to use this over here. So on the left hand side, so if these two is equal, that means dimensions of force equal to dimensions of mass power A, dimensions of velocity power B, dimensions of radius power C. And dimensions of force m, L t power minus 2, and m here is m power A, and velocity is L t power minus 1 whole power B, and R is radius L power C. Rearrange and compare the powers on either of the sides. Minus 2, m power 1, L power 1 minus t power minus 2. Then there is no m over here, so it is m power A remains, and then here L t power minus 1 whole power B. So the B gets multiplied to both the terms. So it is going to be L power B t power minus B, and then L power C. Then on the right hand side, so this is m power 1, L power 1, t power minus 2, then m power A, L power B is here, L power C is here. When you add the powers, L power B plus C and t power minus B. Just have to compare these two sides. When you compare these two, then on the right hand side m power A is there, on the left hand side m power 1 is there. So comparing the powers on either of the sides. Comparing the powers on either sides. the sides. A is equal to 1. Second, here L power B plus C is there, L power 1 is there. So B plus C equal to 1, and T power minus B on the right hand side, T power minus 2 is on the left hand side. So minus B equal to minus 2. So because B equal to minus 2, cancelling like this minus and this minus, B is equal to 2 and A is equal to 1. And because B is equal to 2, 2 plus C equal to 1, C equal to 1 minus 2, C is equal to minus 1. So substitute these values back in, say, we call this equation number 1. Substitute these values in 1. So the first equation becomes like this: F is equal to M power A, V power B, R power C. F is equal to M power 1, V power B, B is 2, and R power C, C is minus 1. So F is equal to M V square by R.